How do fish move? Even a child can answer this question. They swim. However, this answer is not definitive. First of all, there are flying fish. Of course, they don't fly around the planet looking for a nice place to stay, but they are capable of performing some beautiful stunts in the air. But there's also something else. Look at these images of fish moving along a cliff against the flow of water. What is this? An upside-down video? Some kind of elaborate fake? Well, none of those answers are correct. It's actually a very unique species of fish. Actually, several species. In Central and South America, for example, you can find the sucker-mouth armored catfishes. The mouth of these freshwater fish works as a suction cup, which allows them to stick to the surface and stay there despite the fast flow. However, this is not enough to move quickly on the rocks without falling off. But this fish is easily outperformed by an unusual fish from Thailand, the cave angelfish. Thanks to the peculiarities of its body structure, this fish is able to walk, and not only on horizontal surfaces but also at a 90-degree angle. This is made possible by an unusual pelvic girdle, which allows the fish to move its limbs diagonally like a lizard. But there's more to it than that. Among the marine fauna, there are other specimens that can walk with their pectoral or pelvic fins, for example, lumpfish. But even so, only the unusual Thai fish can move on any surface, crawling around like a salamander. By the way, scientists believe that studying them can help them better understand how 430 million years ago, after a mass extinction, some animals came out of the sea onto land and traded their fins for legs. Levitation. Now, how do you explain this? The guy made 2 tinfoil boats of different sizes, put them in a container, and they just started floating in the air. The amazing thing is, if you take the air out of the container and pour it into the boat then starts to sink. So, what is it? The thing is that the vessel is filled with a substance called sulfur hexafluoride, which is a heavy gas. But why doesn't that substance mix with the air? Well, because sulfur hexafluoride is 5 times heavier than air. It can't get out of the vessel. For the same reason, the aluminium boat stays on top of the heavy gas layer instead of falling down. Some call this trick the transparent water experiment. By the way, do you know about helium balloons? Everyone knows that if you breathe in the air from them, your voice becomes high and squeaky.
I'm gonna do some more things in mine.
But if you breathe in sulfur hexafluoride, the sound of your voice will be low and harsh, a bit like Darth Vader's.
I find your lack of faith disturbing.
Heat shield. Every material on Earth has its own melting and combustion points, right? Well, not really. Well, originally yes, but thanks to modern inventions, this statement is no longer relevant. In 1993, a British television show showed something incredible. An inventor called Maurice Ward presented an innovative material known as starlight. To demonstrate its properties, the British inventor covered a chicken egg with the shielding material. He then took a blowtorch with a temperature of over 2000 degrees Celsius and exposed the coated egg to the flame for several minutes. At the end of the experiment, Ward took the egg out and cracked it as if nothing had happened. Both the shell and the interior were completely intact, as if it were a regular raw egg from the store. So what is the secret to the mysterious mixture? Ward himself claimed to have worked several years on his invention, mixing various heat-resistant plastics and trying to find the best combination. Nevertheless, the inventor never revealed the full composition of the mixture, saying only that it includes 21 polymers and a small amount of ceramics. What's surprising is that Ward wasn't a chemist either. In fact, he didn't know much about science at all. The British inventor decided to create this compound after a plane fire in Manchester in 1985. At the time, 55 people on board a Boeing 737 died of asphyxiation in less than a minute from toxic smoke. But then, Why hasn't there been a revolution in the construction industry worldwide since the creation of starlight? Very simple. Ward was unable to reach an agreement with the British Department of Defense or any private companies. The amateur chemist was very afraid that the composition of his mixture would be revealed and was not willing to negotiate. In the end, no one was able to unravel the secret, and after Ward's death in 2011, the story of starlight seems to be finally over. Hydrophobic materials. You've probably seen online ads for hydrophobic shoe sprays. It's a very useful invention for people who live in humid regions. But scientists at the University of Rochester in New York have developed something even better. They've created a technology that turns any material into a hydrophobic element forever, without the need for additional treatments in the future. The secret of this revolutionary technology is treating the materials with lasers using micro and nano structures. A certain pattern with a certain depth is applied to the desired surface. The invention can be described as truly revolutionary, and its field of application is not limited to the production of clothing fabrics. In fact, these materials can be used, for example, to create the wings and fuselages of aircraft. This completely eliminates the risk of ice formation. Incidentally, a few years ago, scientists perfected this invention. Thanks to hydrophobic technologies, they've invented a way of treating metal surfaces that prevents objects from sinking. But how does it work? Structures applied to the surface are able to capture and retain air, which creates an air bubble around the object immersed in water. This is what pushes the metal to the surface. In the future, this may help create unsinkable ships. Memory metal. What happens to metal when it's subjected to pressure? Right, it changes shape like almost any solid material. However, there are also exceptions to this rule. This material is known as nitinol, and it is an alloy of titanium and nickel in almost equal proportions. This metal is much more elastic than regular metals and retains the memory of its original shape. Producing this alloy is not easy though, but its unique qualities make it very popular in the market. Nitinol is used to produce artificial satellite antennas, fuses, boilers, bone implants, placeholder pins, and even jewelry. Nitinol can also be used in the production of perpetual motion machines. This was first done by American engineer R. Banks in 1973. The main element of the original device was a wheel with spokes, similar to the one that you see on the screen. Another component of the engine is the nitinol wire loops, which are bathed with cold and hot water. Nitinol reacts to the temperature changes. In the cold cycle, the loop's ends come closer, and in the hot cycle, the ends straighten out, which makes the wheel turn. This engine is not used in the industry, but thanks to its properties, it's really able to work forever if the temperature of the water in the tanks remains the same. Stone in the air. This installation in Myanmar attracts crowds of tourists every year. Many of them believe that the Golden Rock, or as it's called in its homeland, the Kyaiktiyo Pagoda, has a divine nature. Legend has it that it was placed on a rock by two Burmese spirits 2,500 years ago. The main version claims that the pagoda has the hair of the Buddha himself inside, which prevents the stone from sliding. Well, the temptation to believe that this structure was created by divine beings is really great when you look at it. How can a 7-meter rock stay on the edge of a cliff for so many years, almost without touching it? Well, honestly, scientists have not been able to find a definitive answer to that. Some geologists believe that the Golden Rock is the result of a volcanic disturbance, but most people accept the stone's divine origin.